Students, we are given this question. Using integration, find the area of the region bounded by x-axis and the tangent and normal to the circle x squared positive y squared is equal to 4 at 1 comma root 3. Now we are given the circle x squared positive y squared is equal to 4. So this means the circle which is of the form x squared positive y squared is equal to a squared has a radius of 2 units Okay, so if you were to draw the circle and you got 2 units here, so the circle is going to be passing something like this. Okay, 2 units, it's not to scale. Okay, minus 2 plus 2 and this is 0 comma 0. Now what we have to know is exactly at 1 comma root 3 there is a tangent. So if this point is 1 and if this point is root 3, so at 1 comma root 3 there is a tangent which is striking. Okay, now this tangent has also a normal. So let us draw a normal, okay, at the same point 1 comma root 3. Now the question is, we are expected to find this region of integration. Okay, now I know this point is 0 comma 0, but I don't know this point. Okay, I'm not sure of this particular point, and I know this point. Now this is a tangent. Now there is a formula which you have to know. Now the equation of a tangent to the circle is given to be as x1 positive y1 is equal to a squared. Okay, of course the equation of a circle is taken to be as x squared positive y squared is equal to a squared. So if my point is x1, y1, the equation of a tangent to the circle is very important thing is the point at x1 comma y1. So at x1 comma y1 is given to be as xx1 positive yy1 is equal to a squared. So if x1 is 1, this is going to be x of 1 positive. If y1 is root 3, this is going to be y of root 3, and a squared is the radius, which is 2 squared. So rewriting, I get x positive y times root 3 is equal to 4 units. Now to find the x intercept, we need to put y is equal to 0. So when y is equal to 0, we would get x is equal to 4. So this point is going to be 4 comma 0. So this is a triangle 0 comma 0, 4 comma 0 and 1 comma root 3. Of course you got the lines. Now we know the equation of this line. We have to know the equation of this line. This is the normal. Now since we know the equation of this line, so let me write it down here. We know the tangents equation, right? Tangents equation. So what is that? That's going to be x positive y times root 3 is equal to 4. But this is not going to be doing any help or any favor to us, because I want to rewrite this equation as y is equal to mx plus c. Why? Because I will know the slope of the tangent. M is the slope of the tangent. So let me write it down like that. So y times root 3 is equal to 4 negative x. So from here y is equal to 4 divided by root 3 negative x divided by root 3. This is nothing but 1 over root 3. I want to take the negative sign out, so that would give me negative of 1 over root 3 x negative 4. So this is what is. So from here I can clearly see that the slope of the tangent is negative 1 over root 3. Now this implies the slope of the normal would be equal to root 3. You know why? Because they are perpendicular to each other. So m1, m2 should be equal to negative 1. Now if this is 1 divided by root 3 with a negative sign, then m2 should be root 3, so that their product will be negative 1. Now this line we need, okay, so this implies the equation of the normal should be y negative y1 is equal to m times x negative x1. So y negative y1, if I were to take my y1 as 0, 0, okay, so if this is going to be, because it's passing through 0, 0, you know, I think the best way is not to take it as 0, 0, because in case if I'm not sure of it, so I will just take the point y1 to be as root 3. So y negative root 3 is equal to, slope is root 3 times x negative x1 is 1. So from here this is going to be y negative root 3 is equal to root 3 times x negative root 3. So this was going to be y is equal to root 3 times x negative root 3. I move this root 3 to the other side, it will become positive root 3. So they get cancelled, giving me y is equal to root 3 times x. So I've got the equations of this line. Now all I need is, I need to integrate, I need to find the region that they are enclosing. So the required area is going to be equal to, what I will do, I will integrate along the line. So that would be 0 to 1. X is varying, so it's going to be dx, and y is given to be as root 3 times x, followed by, I need to integrate along the other line, right? So that is going to be equal to 1 to 4 dx, x is varying. Now I have been given x positive y root 3 times 4. So if I were to rewrite that, I'm going to use the space here. So let me rewrite that. So y times root 3 is equal to 4 negative x. So from here, this is going to be y is equal to 4 divided by root 3 negative x divided by root 3. So this is what we have to substitute it over here. So if I were to substitute it, that I would get 4 over root 3 negative x over root 3. So I need to just do the integration. Now this is equal to root 3 times x integration will be x squared over 2. The limits are 0 to 1, positive 4 over root 3 times x negative x squared over 2 times root 3. The limits are 1 to 4. So when you substitute these limits, you would get root of 3 divided by 2. Upper limit is 1, lower limit is 0, followed by 4 over root 3. Substitute the upper limit, it's 4, followed by, again you substitute the upper limit, 4 squared divided by 2 times root 3. Now you substitute the lower limit, 4 over root 3 times 1, negative 1 over 2 times root 3. So after making the substitution, you simplify. This is going to be root 3 over 2, positive 16 times root 3. Now 2, this is actually 16, right? So that's going to be 8 over root 3, negative 4 over root 3, positive 1 over 2 times root 3. Now I can simplify these. Okay, what I'm going to do, I'm going to take root 3 as a factor, or I would say as an LCM. So that would give me 16, negative 8, negative 4. And let me do the simplification for 1, 2, 3. Okay, I don't want to include this one. So let it stand out. So this is going to be root 3 over 2. Now 16 and negative 8, negative 2. So that is going to be 12. So 16 negative 12 will give me 4 over root 3, followed by 1 divided by 2 times root 3. So now if I were to take the LCM as 2 times root 3, so that would give me root 3 times root 3 over here, and 8 over here, and 1 over here. So that's going to be 3 positive 8 positive 1 divided by 2 times root 3, which is 12 divided by 2 times root 3, which is going to be 6 divided by root 3. I don't want root 3 in the denominator, so I multiply by root 3, the numerator and the denominator. So that would be giving me 6 times root 3 divided by 3. 3 divides here 2 times, so I'm getting 2 times root 3 square units as the solution for my question.